Hi everyone. I think you cannot see me, right? Oh yeah, now you can see me. Hi everyone. It's so nice to be back here with you. Uh, I think let's start. Let's begin with this. Hi everyone. Hi Paron. Hi Rona. Hi Green Yoshi X. I think it's pronounced. Hi everyone. Welcome back again to another Global Hack Week. My name is David. You can tell me David. You can tell me David, however you want to call me. And yeah, my name is David. I'm a software engineer at Aspen Tech. I'm also a coach here in MLH. Um, I've been streaming for almost a year with the MLH. I'm so happy for being on such amazing global hack week, such as this global hack week of AI ML. So how has you been your global hack week yet? Hi Wumble, hi Eleanor, LNTPR. I always had problem with those names. Hi Subhankar, right? Is it pronounced Subhankar? Uh, yeah, let me know if it's pronounced Hanka or something like that. Like I'll try to pronounce it as the best way as I can. Yeah. I know we talked yesterday. I know. It was a total disaster. My workshop of NLP was a total disaster. There was a lot of uh, background noise and all the stuff. But let's hope that this stream gets better. And yeah, welcome everyone. So let's begin. Let me introduce myself by sharing first some slides. And my camera is kind of weird because I'm looking at some monitor that is in front of me, and you're right here. So it's going to be kind of weird. You should see me like this, but I'm at the office. So yeah. But yeah, let's just begin with this. Let me share my screen by just sharing some window here. And I don't know why I can show you this. Yeah, I think now you are able to see it, right? No, you're not. Oh, now you are. Hi, Nithyashree. Nitrashi, is it pronounced Nitrashi? Hi, Treasure Data. Hi, everyone. Welcome back again. Welcome, everyone. So yeah, let's just begin with this. So again, welcome. We're going to learn a lot of things today. This is going to be a real theoretical workshop. So be ready for learning a lot of stuff. If you have a notebook, if you want to make some notes, or if you want to see the slides, I'll share it with you at the end. And yeah, so welcome everyone. Welcome to the introduction to RAG ads with Webby8 and Hugging Face. So as you can see, we're on the Global Hack Week ML on AI, and my name is David Lazaro. You can tell me David, however you want to call me. I'm fine with that. And yeah, let's start. So I'm David. I'm a coach at MLH. I'm also a software development engineer here at Aspen Tech. I'm a GitHub Campus expert, and I work in community in a lot of communities as a GitHub Campus expert. I'm the founder of Tigre Hacks, which is a hackathon here in Mexico, and for being more precise, it is on Monterrey, Nuevo Leon, which is a state at the north of Mexico. And I love hackathons. I love the hackathon community. I love always being a mentor or organizing or helping others to organize their own hackathons for building more hacker communities. I also was once upon a time 2 years ago a fellow on the summer 2022 batch at Meta. I worked as a production engineer fellow in Meta. So yeah, I was a MLH fellow in the Meta 2022 summer production engineer batch. And I also have a group of friends that mostly we are kind of nerds, some kind of a nerd group that loves machine learning, NLP, mathematics, and all the stuff called MLCats. And currently, I'm building a tax startup, a research tool, and more things that I think I'm not able to say. But yeah, so nice to meet you, everyone. If you have any questions, just let me know. So yeah, let's begin with this. What is RGA? RAG, sorry. So RAG is Virtual Augmented Generation. So basically, it is a process of optimizing the output of large language models. So it references an authoritative knowledge base outside of the training data sources before generating the response. And what does this mean? This means that basically large language models are trained in vast volumes of data and use billions of parameters for generating original output for tasks like answering questions, translating languages, and completing sentences. But the problem is that they are only trained with those kind of data. So, for example, if I'm a company that dedicates itself to sell avocados or something like that. Maybe my avocado doesn't appear on this data knowledge database or something like that. So what my avocado is going to do is going to uh, use a database, my own avocado database. So my own avocado database is going to be stored in somewhere in the internet, and I'm going to use some kind of tools to try to expand the knowledge of my LLM. So is that okay? Okay. I'm going to assume that that is okay. But yeah, RAG extends the already powerful capabilities of LLMs so to specific domains or organizations' internal knowledge base without the need of retraining the model and all this stuff. And it is super cost effective. It helps you to approach to improving your LLM output so it remains relevant, accurate, and useful in various contexts. So as you can see, there's this person who is going to ask something to the LLM, and the LLM is going to say, huh, okay, cool question. I'm going to see if I have it on the back side, and then I'll return with the answer. Okay, so then the element goes to its vector database. It could be SQL, NoSQL, whatever you want to use, and it's going to return some answer. And the answer is, well, it's going to retrieve like the response of the database if the vector database got something on the back. And it's going to return it to the LLM, and the LLM is going to process it with some help of prompt engineering. But yeah, until now, this is like the basics of RAG or retrieval augmented generation. But what is so important? Why should we use it? So as we know, LLMs these days are key artificial intelligence technology powering intelligent chatbots and other natural language processing applications. And the goal is to create bots that can answer user questions in various contexts. For example, if I work in government, or if I'm working on my company, or if I'm building a chatbot for my avocado company, maybe I have some questions about kind of avocados, amounts of avocados I have this year, and things like that. So we go on and on and on. And maybe if I work in government, I have some process like processing tramits or documents or things like that. And in government, we store a lot of documents. So documents have a lot of text, documents have a lot of stuff. So maybe I can build a chatbot for my government for helping my government to answer like questions to the citizens of the city, to answer questions like which was like the last use of our current salary or something like that, like which was like the best salary in the city, or which was the use of the money that we had last year, and which things was it used in like the streets and lighting and things like that, or in my avocado company, which was the most sell avocado in the year. So maybe it was this kind of avocado, maybe it was a different kind of avocado. But yeah, the problem with this is that large language models are not really that intelligent. They don't know they don't have like all the answers in the world. So we need to help them. So there are a lot of challenges with working with LLMs, such as presenting false information. Maybe, for example, if I ask this and my LLM doesn't have like that current answer, maybe I'm going to see something as your best selling avocado was the Charlie Brown one, and maybe Charlie Brown doesn't even exist in my database, right? And also you can get data that is not specific or out of date. Also, we can create responses from non-authoritative sources. Maybe the information that I'm getting is not good. Maybe the information that I'm using as a retriever doesn't even exist, or maybe it is false. Maybe it's just some random Reddit or Discord comment that someone mentioned, like, "Hey, you should totally do that," and that is false, right? But yeah, also another problem is creating inaccurate responses due to terminology confusion when different training sources use the same terminology to talk about different things. So, for example, maybe if I talk about avocados, I talk about the fruit, right? The avocado fruit. But sometimes in the software, in the tech industry, avocados are mentioned to developer advocates who advocate technology in their own companies or advocate the technology that their company uses and things like that, right? So yeah, let's continue with this. So there's a clear example right here. Well, oh, sorry. The benefits of implementing RAG are that they are cost-effective implementation. They have current information or information that is not out of date. They has enhanced user trust, and they can have more developer control. So an example here is maybe I want to ask ChatGPT or some of these great LLMs, who was the most interactive hacker in the community on the last Global Hack Week? And the answer of ChatGPT is going to be something like, as an AI, I don't have the access to real time or future data, blah, 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 blah. And basically, he's going to say something like, I don't know, why are you even asking me? Who are these hackers? Are you going to hack me? No, I don't want to hack you, ChatGPT. I just wanted to learn which was the best or the most active hacker on the last Global Hack Week. But ChatGPT doesn't have that knowledge yet, so we're going to just continue with it. We're just going to let it be, but we're going to work with that to make ChatGPT better, right? So how does ARG or work? So first of all, they create external data. So the first thing that we need to do is create these databases or vector database, whatever you want to use. So this new data is going to be outside of the LLM original training data set, and it's going to be called external data. So it can come from multiple data sources, such as APIs, databases, document repositories, etc., etc. So as you can see in this image, we can use even like slides from PowerPoint, PDFs, Excel's, Notion pages, Salesforce data, Slack data, Discord data, Google Documents, YouTube videos, vector databases, and things like that. And then we're going to use something called retrieve relevant information that it basically is going to perform some mathematically searching. And this searching is going to be called semantic search. We're going to see that in the future in this stream. But basically, the user query is going to be converted to a vector representation and matched with vector databases. So after that, after getting like the best match of that query, or like the best match of the most representation of that vector, we're going to return that to our LLM. So we're going to augment its knowledge. All right. So the RAG model is going to augment the user input or prompt by adding the relevant retrieved data in context. And this step uses prompt engineering techniques to communicate effectively with the LLM. The augmented prompt allows the large language models to generate an accurate answer to its queries. So for example, we have this image here that we have something like the description, like a prompt with some kind of sections of the prompt. So for example, we're going to have a description called, this is a movie review sentiment classifier. Review, I love this movie, this review is positive, review, what a waste of time, and this review is negative, and so on, so on, so on. And the current input is going to be review, I enjoyed this movie, and the review is, and so we're going to pass that as an input of prompt engineering, and the large language model is going to output positive because we're trying to teach our large language model how to do that, how to recognize that by just using prompt engineering. All right. So after that, we're going to update our external data. So maybe we have some questions like, what if the external data becomes stale? So to maintain this correct and with current information, we're going to update asynchronously the documents and update embedding representations of the document. It's just a really curious word, embedding. So what is an embedding? Like, why do I want to use that, right? So we're going to see that in the future in the next slide. But first of all, let's try to search something about the architecture of a RAG application. And the first step is just to make our prompt or query, and we're going to pass that to our LLM. And then after that, we're going to create some query, right? The LLM is going to see that we're asking something that maybe the LLM doesn't know. So the LLM is going to make a query to our vectorial database or something like that. and we're going to search for relevant information in our databases or in our knowledge sources. So after going to the back part of the shop or something like that, we're going to see if we have that kind of information, and if we don't have that kind of information, we're going to return that, right? So after returning everything, we're going to pass the relevant information for enhanced context to our LLM, and then our LLM is going to use our prompt engineering, or like the prompt that we pass to our RAG application, and it's going to use it with plots, with the query, and with the enhanced context, and it's going to pass all this stuff to our LLM model that we have, like an endpoint, maybe it can be an API or something like that. And after all this stuff, we're going to pass like our generated text response to our to the user or to the application that we are creating or something like that, right? So yeah, I know that is a lot of information. That is a lot of things. So are we going to hack now? And the answer is no, not yet. We need to understand some more things before getting into hacking, because I told you this is going to be a real theoretical stream. We're going to study a lot. We're going to learn a lot of things. But yeah, we have to wait a little bit more before getting into the code. So yeah. So why do we need to do that? Is because we need to learn how to implement some things first. And the first of all is the semantic search um, concept that I told you, that have some really in-depth things that you need to understand before all this stuff. So yeah, semantic search. So semantic search is a search engine technology. So as you can see here, as we saw, we need to search relevant information. But the question is, how do we search that kind of information, and how does the computer understands what the best option is, or the most relative uh, maybe context, or the most relative document or something like that, can help us with that. So the semantic search is a search engine technology that interprets the meaning words of phrases. So as the example here with the word, well, with the sentence, who was the most active hacker in the community on the last Global Hack Week, the semantic search is going to pass all these words or all this sentence into some things that I'm going to explain now, and it's going to do mathematical operations. Oh wow, I don't know what happened with Davis. But yeah, it's going to perform a lot of mathematical operations and some concepts that we saw yesterday on the NLP introduction, that we're going to see now. And but yeah, it looks for the best match of this, and it is going to return us like the best match. But how does the computer understand my words and sentences? How does my computer does it? So there's one thing called embeddings, and it's the answer for all your questions, and is basically like the key point of every large language model, of every semantic search, of a lot of things. And embeddings work with vectorization and work with a lot of mathematical things that I'm not going to explain today. But if you want, you can search for some theory called vectorization, and some other stuff call it tokenization, that are basically principles of NLP. Let me just see the chat before continuing. So Samhankar Ray says, search engine. So it's a more open form of ChatGPT having access to extra information. Yeah, you can basically say that. So ChatGPT is a really big LLM. ChatGPT is a model that it has been trained with thousands and millions of data. And LLMs basically do that. Some LLMs doesn't have that kind of data. Some LLMs are trained specifically for answering some kind of questions and things like that. But like the main idea is to have your own LLM, and with that LLM, expand the LLM knowledge without the need of having to retrain that LLM. Is that good? Is that clear? Let me know if you have any questions. You can put whatever question you have in the chat bar, in the chat section, so I can answer it, or if we can talk or discuss about that. So yeah, embeddings. So embeddings are vectors. So, vectors are these kind of arrays that have like multiple um, kind of data, but basically they are vector mathematical vector representations of data where linear distances capture a structure in the original data sets. So as you can see here, we have some kind of vectors of words. So basically what we're doing is to pass uh, a word or a sentence into some kind of vectors or mathematical vectors, and basically by embedding model, we're going to pass like that word to our embedding model, and we're going to have some kind of results. So this data code consists of words, in which case we all call word embedding, but embedding can also represent images, audio signal, chunks of a structure or unstructured data like documents, like images, like music, like video, etc., etc. So basically, we're going to pass this main word to our different embeddings that we have, and we can see in our image here that we have a visualization of a word embedding, right? So for example, man is a person, is a living being, is a human. Woman is also a human, is a living being, and things like that. So in our two-dimensional vector space, we can see that woman and man are some kind of short in distance. They are really similar. And so the same thing happens to king and queen. In our visualization of our word embedding that we have, queen and king have like the shortest distance between them. So for example, if we compare something like woman and queen, maybe the distance is going to be super big, is going to be so large. But if we try to compare woman with men, it's going to be the nearest neighbor that we have yet. So maybe if I ask something about men and women, and it's going to relate them, and the searching is going to be really good. So embeddings are foundational because they provide a common mathematical representation of your data, and they compress your data, and they preserve relationship with your data, and they are the output of deep learning layers, providing comprehensible linear views into complex nonlinear relationships learned by models. So yeah, I know it's a lot of things. There are a lot of mathematical stuff that is behind. I'm not going to explain it today because if I want to explain it, it will take me hours and days to just try to explain that stuff. But yeah, and also let's try to see some kind of examples, right? Real world example of this. So yeah, so let's look at this classic example. So let's try to imagine that we have the same data set, the queen, king, princess, prince, or man and woman thing, something like that. For now, let's just going to assume that we're using a data set that just contains queen, king, princess, and prince. So basically, we can use some NLP mathematical algorithm or an NLP process that is called hot encoding with a three-dimensional sparse vector. This means that we will need three columns which contain mostly zeros. So what I mean with hot encoding, you can watch the NLP fundamentals for understanding what hot encoding is. If not, just Google it like super quick. But basically, hot encoding is like, for example, we have column queen, we have column king, and column princess. So imagine that we have these four words. So queen is going to be activated by saying that the column queen is activated. So it is going to be the only one and the only column activated. And when I mean activated, it means that it has a one. And the same happens with the king. The column queen is going to be deactivated, and the column king is going to be activated, and column princess is going to be deactivated too, right? Like 0, 1, 0, and queen is 1, 0, 0, and princess is 0, 0, 1. And prince, because we don't have a column of prince is going to be 0, 0, 0 because we don't have a column for identifying what a prince is, right? So yeah, let's just going to continue with this. What do you think would happen if we, instead of using this, we would try to, instead of using this kind of columns, we will we use something like instead of using different columns that we can identify as, hey, is it female? Hey, is it old? Is it young? So in this case, we were just going to say that, is it female? yes or no, and is it young is yes or no, right? So the column female is going to do the same thing. We're going to do hot encoding. So queen is female, king is not, and is queen young? It is not. Is king young? It is not. Princess, is it female? Yes, it is. It is young too. Prince, the same thing. It is not female, but it is young. So with this stuff, now that we have differ along the two dimensions, we can see how this data is represented, right? But not only we get rid of the column, but we also preserve valuable information. Obviously, this is like a super little example of embeddings. It doesn't tell us a lot of the stuff. But what if our corpus contain every word in the English language? What if we have a data knowledge that have every word in the in English knowledge, right? So embeddings are going to be passed to like the words that we have currently, like man, woman, king, queen, blah blah blah. Imagine that we have like all the like columns for each word in the English vocabulary. So we can do something like that for generating our space or word embedding. That we know that this word embedding is like a two-dimensional space, but it is not two dimensionals. It is one dimension for each word in the English vocabulary. So what we want to do is to kind of set by the mathematical representation of this stuff, of these words. So for example, man, maybe this 6 means that it is human. This 0 dot 2 means that it's object or things like that, so on, so on, so on. So we can build like the representation of the position of our word in our word embedding. So we're going to match our word for each word that we have in our vocabulary in the English alphabet, no, in the English vocabulary, and we're going to set some kind of position into that embedding, right? And yeah, basically is that. If you have any questions, let me know if you have any questions. But the main idea is embeddings are vectors that help us to convert words in mathematical vectors that computers can understand. And basically, these ones kind of set a position of a word inside a dimensional word embedding that computer can understand. So we can compare, make vectorial operations, and with these vectorial operations, we can do things with these words. All right, so let's look at a real world example. So imagine that we are driving a Tesla, or that we have just bought the latest Tesla in the market. So this Tesla is going to help us to understand a lot of stuff. So maybe we are engineers at Tesla and we have built a Tesla, but Tesla has asked us to kind of enhance the computer vision algorithm of this stuff, right? So maybe the Tesla is on the US or Canada, and I want to drive my Tesla from the US to Mexico. And instead of seeing the stop sign, I see something like alto. So alto means stop in English. So it is something that we have never seen before, or maybe we saw this like line sign. So we're going to pass these images to our embeddings that we know, as we said, embeddings are not just for words. Embeddings are also for images, for music, for videos, and things like that. So we can classify these images. We can classify it by, hey, is it a sign stop? Is it a sign signal? Is it a stop signal? Is it in English? Is it a symbol? Is it an octagon? And things like that. So we can put our own columns for creating our own embeddings, and we can kind of get something for these embeddings for getting a numerical classification, right? So as we can see, the stop signal has like all the all unless the symbol, unless the symbol columns, all the columns are activated, and for the white sign, the yellow sign, it is a mixed classification. For the alto one, we have like we don't know if it is a stop. We don't know if it is in English. It is not. It is not a symbol. it is an octagon and it is a sign, so we can classify it by that, right? So after doing all the mathematical stuff, we can see how our vectorial space is built. We can see that we have some like the red signs are together and the yellow one is like super far from the red ones. So yeah, this is a cool example of how we use embeddings in the real world. And now we're going to continue with this and just try to see something in action, right? So if you still don't get it, don't worry about it. We're going to learn how semantic search works. So semantic search is powered by vector search, the things that I just showed you, that we have to create some kind of vectors for generating all this stuff. And this vector search is going to enable us, our semantic search to deliver and rank content based on context relevance and intent relevance, right? So vector search is going to encode details of searchable information into fields of related terms or items or vectors, and then compares the vectors to determine which is the most similar, right? So if, for example, I go to other country and I see a red octagonal signal that has a different word that is stop or auto, is going to be probably it's going to be real probable that this sign is on the side of, it's going to be near to the red signals that the red signals than the yellow ones, right? So that is how we compare that stuff. And this vector search is going to be enabled by semantic search. It's going to produce results by working at both ends of query pipeline simultaneously. When a query is launched, the search engine transforms the query into embeddings, which are numerical representation of data and related context, and they are going to be stored in vectors. So for example, I pass the same query to my LLM, and for example, if I ask to my LLM who was the most active hacker in the community on the last Global Hack Week, I'm going to see that this sentence is going to be transformed into some numerical vectors, and these vectors are going to pass to my embedding model, and the embedding model has these like hidden layers that we don't want to see currently. But what you want to do, or what you want to learn is that is that we're using the closest neighbor algorithm, or the k-nearest neighbor, and we're going to match the vectors of existing documents or words or whatever kind of embedding that we're using. And the semantic search is going to generate the results and ranks them based on conceptual relevance, right? So I know we have seen a lot of stuff. I know it is a lot of theory, but yeah, we're almost there. We're almost into the hacking. So yeah, when a query is launched, the search engine transforms the query into embeddings, which are numerical representations of data and related contexts. They're stored in vectors, and the k nearest neighbor algorithm is going to match the vectors of existing documents and to create these vectors. And then the semantic search is going to generate results and ranks them based on conceptual relevance, right? So, okay, I know it has been a lot, but the good news is that we are almost there. We are almost into hacking. So, David, what are we going to do now? Like, okay, I know, I understand we have to do some theory for generating information for my model. So, before that, let's just going to take 2 minutes or 1 minute into for answering questions. So, if you have any kind of questions until now, let me know. If not, we can continue. But yeah, I'm just going to give 1 minute at 5:40. Well, in 1 minute, I don't know which hour is there where you are watching. Uh, but yeah, the humans create embeddings. Yeah, we as humans can create those embeddings. So as we can see here, so as you can see here, these three columns are super different, like the ones that we have, right? And not all embeddings are the same one. I mean, I can use an embedding with all the words in the English vocabulary, but I can create another embedding by I don't know, all the words on the Chinese vocabulary and things like that, or for maybe sign for strict signals, or maybe for images and things like that. Embeddings are created by machine learning engineer or AI engineers, and they I have a lot of mathematical stuff that I'm not going to explain right now. But yeah, and too long didn't read embedding side created by humans. Uh, how do I use the Rickroll feature? I don't know. Do we have a Rickroll feature on Twitch? Let me see that. I don't know. Let's see. MLH. Uh-huh. Are you trolling me, or do we need a? Do we actually have a Rickroll feature? Oh, yo, but I'm good job, Bong, Law Track. Rickroll? Oh my god, you have a lot of points, man. There are 10,000 points. Oh my god, you're real active. uh one blah, 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 blah. To be honest, I don't know. I didn't even know that we had like Rickroll things with Twitch points. But yeah, let's just continue. To be honest, I don't know. You can ask in the chat. Let me ask that. Let me ask that on the private coaches Slack. Uh, yeah, yeah. Don't worry about it. Just give me a minute. Hey there. How are the points called? You need to call it Twitch point. I don't know anything about that video, but hacker, he said almost channel points. And he wants a refund. Now, what should I? Is there any moderator that can help me with that? Okay, I passed already like the message to the MLH channel, so don't worry about it. I'll think some moderator is going to take care of that other stuff, so don't worry about it. We're going to work in that. Besides that, uh, besides that, anyone has other question? If not, I'm going to continue with the stream. So, just 1 minute. I'm just trying to see if someone responses. Okay, some Wei told me that I can get into the Twitch channel for yeah, it is on the Dimmer streams. Yeah, you were right. Dimmer is the one who's able to hook up the rig rolls. But yeah, okay, so I think I'm going to be the one who is going to be in charge of that. Send me a DM by Discord so I can help you at the end of the stream. And yeah, we're going to continue with the stream. Is that okay? Is that okay, Wombo? Are you okay with that? So we can take care of that problem at the end of the stream. And if not, I'm going to ask someone else to do that. All right, sounds good. So we're going to continue, right? So let me pass you first of all. Let me pass you some kind of cool stuff that we're going to do today. So we're going to follow our tutorial of WebB8, that is that the database that we're going to use today. So if you have never heard of WebE8, WebE8 is an open source vectorial database that basically vectorial databases are databases that can store any kind of information. So as you can see here in this like example, we can have clients, we can get articles, we can get documents, we can get a lot of stuff, and we can get data from this vectorial database. And it uses semantic search, the one that we have just learned today, for creating this, using these algorithms and these embedding models for searching for the best option, or like the most closest option that we have for some query that we make, right? So I think I haven't passed you the link, right? So let me put it on the chat. So yeah, I think I have passed you already the. Yeah, yeah, right. So yeah, so WebE8, it works with a lot of languages like Python, like JavaScript, and things like that. It allows you to empower developers, create different kind of searches, use a lot of the integrations, documents, and all the stuff. It also has a really good community. It also have like a really cool stuff that you can use, like resources like Academy for learning how to use the database, how to build applications with WebE8, and like the basics of WebE8, like how to what is a schema, what is WebE8, how to create queries, and things like that. So yeah, WebE8 is super cool, and we're going to use it today. So the first thing that we're going to do is going to try it out and allow everything, and then create our vectorial database into our cloud service of WebE8. So let me know whenever you are into it. So I'm going to wait until you are here in this dashboard so you can create your first WebE8 vectorial database. And let me know. Oh yeah, you're not seeing this, right? Oh my god. Okay, give me a minute. Yeah. So I think I didn't change the tab. So let me change my tab. Let me get into. All right. Yeah. So you should click on the try now button on WebE8, and after doing that, I think now you're seeing that. Yeah, you're seeing it. So after that, just log in. You're going to see this screen, and click on login to WebE8 Cloud Services, and you're going to see this. If you don't have an account, create your account. I already have my account, so I'm going to wait until you have your account already. And after that, just log in. You're going to receive like an email confirmation and all the stuff. So yeah, after that, you're going to see a dashboard like this. So I'm going to wait until you are in this dashboard, and after that, we can continue. So while I wait with that, I'm going to pass you another link that we are going to use today. It is Hugging Face. So Hugging Face is another cool platform that we can use for hosting models, and also model from all kind of stuff like LLMs, image classifier models, maybe text to something, like we can have like visual models, graph models, object detection models, video classification models, the text classification, token classification, text to speak, text to audio, audio classification. We have a lot of models that we can use on Hugging Face. But yeah, I'm going to wait until you do that. And if you already have your account, then I'm going to explain you a little bit more about Hugging Face. So yeah, this is Hugging Face. Hugging Face is a really cool community platform like GitHub or like GitLab or things like that, where you can host your models, you can create your own spaces, create solutions, create a lot of stuff for you. So for example, you're going to see that we have a lot of stuff here. We have a lot of models like MetaBoys, like RMBG. We have also Smoke and Miku. And we have also a lot of data sets that can help us to do a lot of stuff with the community. Like, for example, awesome ChatGPT prompt, right? And for example, I can have something like a prompt that can help me with prompt engineering. Like, I want you to act as a Linux terminal with type commands, and you will reply what the terminal should should show, right? I want you to only reply with the terminal output inside a unique call block and nothing else. Do not write explanations. Do not type command unless I instruct you to do so, and blah 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 blah. So we have a lot of prompts that we can use for this chat for ChatGPT and prompt engineering. But yeah, basically, Hugging Face is a really cool platform that you can use for a lot of stuff. It helps you a lot with uh, building your machine learning portfolio, with accelerating your career in machine learning and NLP and things like that. So also, it is the main house of transformers, which it is another big technology that I'm not going to explain today. But the only thing that you should know about transformers is that transformers are super cool. They are like the key of all LLMs, of the most recent LLMs and stuff like that. So don't worry about it. We're going to learn it, or we're going to see how to use transformers inside our application. And yeah, this is Hugging Face. The only thing that you need to do for accessing to Hugging Face is just click into the login or into the sign up page, click on login or creating your account, and ta-da, you're going to be inside Hugging Face. And yeah, let's just wait until everything is um, no way, you're David I don't know who's David Leal. My name is David Lazaro. So my name is David Lazaro, and yeah, or David Lazaro, but it is right like Lazaro. Yeah, don't worry about it. Yeah, I used it today to create a comic. Yes, the comic creator. Yeah, yeah, I know. Yeah, comic face is Hugging Face is super cool. We have a lot of stuff that we can use for that. But yeah, this is Hugging Face. I'm going to wait until you have everything. So let me know whenever you have already your Web8 account, and also when you have your Hugging Face account. All right. All right. So I'm going to wait a little bit until you have everything. And while I wait, I'm going to take my avocado and just take a little bit of coffee. All right. So just send me a comment, or like send a comment to the chat if you have already everything. Whenever you are logging into Hugging Face, and whenever you are you have your Web8 account. Okay, so super. All right, right. Oh, excuse me a minute. When the hour finishes, I'm going to go for a little bit more of coffee, and after that, right. Oh my God! Thank you so much, Yansar. Thank you so much. Yeah, thank you so much, and I hope that Wombo has like everything set up. Thank you so much, Yansar and Wombo. There you go. You have already your rebounded point. Thank you so much. And looks like everyone is logged in, or like most of you are already logged in. So we're going to continue, right? So, David, what are we going to do? Why do we want the WebA? And why do we want everything here? And the too long didn't read question. Well, answer is we're going to learn how to apply this vectorial database for creating all the stuff. So we're going to follow some tutorial on WebA for generating our first semantic search engine that we can use for searching some things. So the repository that we're going to follow is the next one, and we're going to use it on GitHub. So I just passed you the WebA repository so you can fork it. You can use it also on your code spaces. And if you don't know anything about what I'm talking about, let's just take a quick look into GitHub. So let me first make a little bit of spam of the student developer pack of GitHub so we can continue with this. And yeah, so GitHub is a real cool platform for developers. Like Hugging Face, if you have never heard of it, I'm sure you have heard of it, but if not, it is a cool platform that developers uses for hosting their own projects or their own code. And a cool thing that GitHub has is that it cares about students. It cares a lot about students, and it brings you a cool GitHub Student Developer Pack. So this student developer pack helps you a lot with some experiences. That experiences are basically built in like tracks or like packages that help you to use the free tools that the GitHub Student Developer Pack gives to you, and resources that are designed for you to learn all this new stuff that you want to learn, right? Like for example, you have experiences for security, for AI prompting, for career readiness, for web development, hackathon, cloud, blah blah blah. If you want to learn how to become a data scientist or a machine learning engineer, if you want to become the best one for cracking your own interview, your next interview, if you want an internship, or if you want to get into your career readiness, like cracking your next FANG interview, that could be awesome. The career readiness experience is super cool. And another cool thing that you have is super really cool offers and like goodies that GitHub gives to you as a student, such as all the IDs of JetBrains for free. Like while you're a student, you have all the IDs of JetBrains for free. Also, you have Namecheap. Also, you have Microsoft Azure. If you want to build something in the cloud, if you want to build like an API, a chatbot thing, image classifier, maybe some kind of word generator on the cloud, you can use Microsoft Azure. If you want to host your own Minecraft server, you have DigitalOcean. You have 200 free credits on DigitalOcean, so you can use it. Other cool thing that you have on GitHub is GitHub Copilot. So GitHub Copilot helps you a lot with autocomplete the code that you're writing. If you want to build your portfolio or just host your next hackathon page or something like that, you have Namecheap, Tech Domains. You also have a Namecheap that is another domain for hosting your own web page. And you have a lot of stuff here. I'm not going to talk a little like all the tools that you have, but yeah, you have a lot of tools that you can use. And yeah, basically, my suggestion will be apply for the Student Developer Pack. Applying is super cool. It's super easy. Just click on the sign up for the Student Developer Pack, get a student benefits, and after getting the student benefits, you're going to see something like that. And yeah, you can use it however you want. So you have GitHub benefits. You just need to upload your student email, like the email that your college gives to you, or you can use it is if your bootcamp is applied for getting all their students into the Student Developer Pack, you're going to get for free, like your Student Developer Pack, you're going to get GitHub Pro, and you're going to get a lot of cool things that you can use here. So yeah, you can also apply to the GitHub Campus Expert program that is the best program in the world. So yeah, and for applying, you just need to pass your email address and all the stuff, or pass if you don't have an email, a college email, you can pass just like your. I think you can pass a document that verifies that you're a current student in your school, and after that, everything should be ready to go. So yeah, and another cool thing that you have for being a student is Codespaces. That is the thing that we are going to use today. So Codespaces, oh my God, this is not the page. So Codespaces, GitHub. There you go. So Codespaces basically is a virtual environment that you are going to have inside your browser. And this virtual environment is like an IDE or some code editor that you can use, like Visual Studio Code, like JetBrains, like Jupyter. You also have a terminal. You have your own computer inside your browser, and you can use it however you want. Also, you have it is faster than your laptop, like in all the ways. You can use like whatever virtual computer that you want to use. And I think the main one that you have is a 4-core computer as like for free. It has 8 gigabytes of RAM and 32 gigabytes of storage, but also you can use a 32 core gigabytes of processor, 64 gigabytes of RAM and things like that. But yeah, you can code inside your browser if you have a cheap computer and you don't have like so much resources in your computer. Don't worry about it. You're not going to consume them all. Everything is going to be run inside your virtual computer, inside your browser, and you can do whatever you want with that. So yeah, there's a lot of blah blah blah. I'm not seeing any action, but you know what? Let's just uh no, we're not going to use that. No, we're not going to use them, but I wanted to show you the student developer pack. And well, the only thing that we are going to use is code spaces and something. Well, this is for me. I'm going to use code spaces. If you want, you can use. I'm going to use code spaces. If you want, you can run it on your local computer. I think code spaces are free for students, or I think code spaces are free for everyone. I don't. To be honest, I don't know. Uh, yeah, yeah, but yeah, like don't worry about it. We're not going to use any of the free tools that GitHub gives you. Okay. So now that we are here, let's go into my GitHub. So I'm going to my profile. This is my profile. If you want to follow me, I'm going to pass it to the chat. Let's follow each other. Let's be friends on GitHub or follow each other. And what we're going to do is to create a new repository. You just need to log into your GitHub and click here into new repository. Click here and choose an owner. You're going to choose yourself. And after that, you're going to select a name for your repo. I'm going to name it Gala Hack Week AI ML. Well, these instructions apply if you want to run the repo that I passed you about WebB8. This one, the semantic search of wines. We're going to learn how to create semantic search for like our first super basic RAG application for wines. So the only thing that you need to do is to, if you want to use code spaces, is click into this button, green button that says code. Maybe you're going to see this thing that says local. So click first into code spaces, and then click into create code space on main. But if not, if you want to run your repository and fork your like the repository of WebB8, the only thing that you need to do is to get here and create your repo and do something like Go Hackweek ML AI. I think it's AI ML rack. I'm going to name it like that. And creating first rack app. And then you're going to pass your README, and after that, you're going to, well, you can also choose a license for it. And after all this stuff, just click into create your repository, and then create it in local. And if you want to use any of the WebB8 resources, also you can fork it out and just clone that, or you can click into the code, search it, and copy and paste everything that we're going to see. But yeah, basically we are going to use this. So yeah, until now, do you have any other questions for now? If not, I'm going to continue. Hi, Amici. I'm Amici Spoyer. Is it Amici Spoyer? Amici Spoyer. Yeah, what? How do you pronounce that name? But I'm going to call you Amici. So is that okay? Right. So if you're here, if you're already like with everything, just click into the code and see code spaces, and then code space create on main, and the code space is going to be set up in your environment. And okay, we have everything that we have now. So one thing, I'm running out of coffee and I'm dying of my throat. I need to calm down a little bit. So what do you think if we bring us like just 5 minutes until I get to go for my coffee, drink a little bit of water, and after that I'll return and we can start with our project, and that we can use also this time for waiting the others for cloning their repo and like getting all the environment set up, right? All right. So I'm going to assume that that is okay, but yeah, I'm just going for some coffee and water, and after that I'll return. Oh, I think you see me, but the lights are kind of killing my camera. So what happens if I do this? Yeah, let me fix that. Yeah, I think it is better. What about now? Oh, well, I mean, it's not that great, but yeah. I'm going to assume that that is okay. And yeah, so let's continue with this. Where I was. Oh yeah, we were installing our code spaces. We were getting the project ready for continue building our semantic search engine. And yeah, let's just try to continue with it. Uh, I like that we are on the talk shows and podcast together. Oh, really? Wow, I didn't know that. That is so cool. Yeah, well, the first hour we went like just chatting and learning and studying like all the stuff that but includes the rack applications and these things. But yeah, let's just continue. Um, okay, so we were here on getting all the stuff. So for getting the record sites, for getting all the stuff, uh, just let's just try to follow the instructions. So first, let's just try to install Docker. So let's do some sudo apt get update. Oh no, I want the preview. Yeah, let me allow my computer to run this stuff, and then let me run the Docker command, the sudo apt get install Docker cli, and then do the same thing, but for Docker Compose. So let's do this. And okay, so yeah, let's just try to do that. And then it says install Python. So we have Python already installed, so we're not going to worry about that. And oh yeah, let me zoom a little bit the screen so you can see it better. Is that good? Is that too much zoom? Do you want me to zoom it out? Um, I'm yeah. Let's get back to cooking. Yeah, I'm installing Docker on my code space because code spaces are different kind of computers. Like each code space is a different system. So maybe in one code space I can have Docker. Maybe in one I cannot because I don't use it. So because this code space is new, I'm installing Docker um, on my code space. But yeah, it doesn't take like that much. So again, let me know if this is enough zoom, if you need me to zoom a little bit more, or if you want me to do something special, right? Um, yeah, so not really on my local hardware, not really on my local machine. I just installing it on my on the cloud of the code spaces. Um, so yeah, let's just continue with this, right? So yeah, okay. So we have this stuff already installed. So I think Codespaces have already installed Python. So let me do Python version, and yeah, we have Python 3.10.13. All right, so we have already installed. So the first thing that we need to do is to create our virtual environment. So I've talked about virtual environment so much. So why is it so important to install virtual environment? Virtual environment are environment that are which was the word? It is are environments that are isolated from the other environments that I have or from the things that I have installed on my local machine, for example. So maybe on my local machine, I have Python 3.10.13, something like that. And I have like libraries like TensorFlow or like WebA and things like that. But maybe on my local machine, I have the version 2, and on my other repository, I had the version 3 and things like that. So by creating a virtual environment, it helps me to isolate all my my dependencies that I have installed on my machine or things like that. So by creating a virtual environment, it helps me a lot to being able to work with others, and also to not to pass my dependencies to maybe my GitHub repo, or to being able to work real well with some other persons, right? And also for not messing around with versions in my own computer and things like that. So yeah, let's just try to create a virtual environment. So for creating a virtual environment in Python, the thing that we need to do is to first make Python m virtual BNB. Basically, this means virtual environment, and it's like the keyword. So we said Python create or make a virtual, like we pass the keyword virtual BNB, that means virtual environment, and then you can choose a name for your virtual environment. I'm going to name it BNB, and just click in it. And oh, so this is for Linux, or yeah, like Linux-based systems. For other systems like Windows and things like that, it is harder, and I would suggest you to take a look into the documentation of how installing a virtual environment in Windows, because it is a mess, and I'm not going to explain it today. But yeah, so let's just create another file called gitignore, and we're going to ignore all the files that we have on our BNB. And after that, like as you can see now on our Git history, we don't have any problems with our BNB. So we have like our Git, like all the scripts and libraries and things like that we have on our BNB being ignored. So nothing is going to be messing around with us. So yeah, and now for getting into the virtual environment, we're going to make something like source BNB bin activate. And as we can see now, we are inside of our virtual environment. And how we can see that is, so in your line or on your terminal, you're going to see at the left that you have BNB. And with that BNB, everything should be ready to go. So yeah, now let's just try to install all the dependencies that we have, and how we're going to do that, and which dependencies that we're going to install. So thankfully, WebV8 has prepared for us like all the stuff that we need to work in this. So we're going to use the next libraries. We're going to use pandas, gRPC-IO, gRPC-IO tools, and we're going to use our WebV8 client that is inside of a WebV8 repository. So let's just do that by doing Python. No, I'm sorry, pip install. Remember, pip is your package manager for Python. Pip install R and the file requirements.txt. And this is going to be like installing all the stuff that we need for working with our WebV8 repository. So while we wait, let's just get into it, and let me know if everyone is already here. And if not, I'm going to help you with whatever problem that you have. So yeah, we have to install our virtual environment. And after creating our virtual environment, activating, and then install all the requirements, we have done that. So now we can just start our WebV8 or our WebV8 repository by running the Docker compose of the WebV8 thing. And it's going to be running on our local host in our machines. So yeah, let's just do the Docker compose up d, and it is going to fetch all the stuff that we have in our Docker compose YAML. So as we can see, we have the versions, the services that we want to use. So it is going to use WebV8. It is going to use a lot of environments stuff. It is going to use an image of WebV8 that we have inside here. And also we're going to use transformers. It is the technology I told you about. And we're going to use the next LLM. We're going to use some transformer called center transformer that basically enables us to make the semantic search and all the stuff that we want to use for using the stuff that we want to do with the wines, right? So we have sentence transformers, Firetrace, multilingual, mini LM, L12 version 2. And while everything is downloading, we're going to just wait and see everything that we have to do right now. So while that finishes, let's just see what else is going to do. So first we need to start up WebV8 by using WebV8 Docker Compose upd. And once completed, WebV8 is going to be running on a local host. And remember, WebV8 is our vector database. And after that, we need to run the Python import.py file to import our 2,500 lines to WebV8. And after that, the data is going to be stored on WebV8 instance, and we can experiment with it using a Python notebook or a Python file or whatever we want to use, right? So there you go. So let's take a look to the import.py file. So we can see that we're using WebV8. We're also using WebV8, importing a class of WebV8 called config, and this config file is going to help us to start our WebV8 client. So if you don't want to run it here, if you wanted to run it like always without the need of being running your computer, you can just go into your WebV8 client and create a new cluster that you can use for whatever you want to use. And you're going to have a free sandbox. Basically, a sandbox is your database in the cloud that is going to be running always. You're going to have a public slide, and you're going to have a single availability zone. Also, you have monitoring and community support, so don't worry about that. And you can just create a new cluster like wines or like hacker cluster for wines. And you're going to create it. Oh yeah, you're right. I need to use this dash. Okay, so dash and then create, and okay, just creating itself, right? So while the sandbox creates itself, well, the only thing that you need to do is to connect with it, and connected with it is super easy. For example, we're using Python. It has two versions, the version 3 and the version 4, sorry. So for example, you can use the 4th version and just work into it. So yeah, using it is super easy. You just need to pass the URL, your API key that is generated in your profile, and you can connect it by just putting this command here. Client WebV8 connect to WCS, which is your WebV8 database in the cloud, and you are going to pass your URL and your auth credentials. That your auth credentials are basically your API key. Okay, so yeah. The list is inside your README. So if you go here, remember we're using this demo of text search wines on WebV8. So what are we doing here is just cloning this repo or looking at it or something like that. I'm just creating a code space on main, but you can also just clone this repo and use it on your local computer. And all the instruction for running this up is on your README file. Basically, your README has all the instructions for installing it, for usage, and all the stuff for installing like all the things that you want for Docker, for Windows, for Linux, Docker Compose, and all the stuff that you want to use, right? So in this case, we're installing Docker. We're also installing Docker Compose. We're also installing Python, also setting up like our environment. We're creating a virtual environment for creating for pulling up all the requirements that we need. And when I talk about requirements, is the dependencies that we're going to use on the project. And after that, we can just continue with it. After installing all the stuff, we can just start our WebV8 database by using Docker Compose upd. And once that is completed, we can run WebV8 on our local host. And actually, it is already running. We're already running our WebV8 database. And yeah, as we can see here, we have like the main information about our database. So if we go into our localhost, we're going to see that we have the information about documentation, about how to create schemas, how to create triggers, how to create classification, and so on, so on, so on. So yeah, and now that we have running our databases, the only thing that we need to do, let me see what it's running here. I don't know. It looks like we don't need to care about that. But yeah, now that we are here, the only thing that we need to do is to run the next Python command, that is Python import.py. Yeah, import.py. And we're going to start importing all the wines. So basically, where we want to fill up with we want to fill up our vector database with some wines that we have here. And when I talk about wines, is just getting the collection of wine reviews. And after doing that, we're going to create all the collections of these wines, and for each wine, filling up everything, right? Okay, so let's take a deep look into the import.py code. And let me see if there are some comments in the chat or some questions. Nope, looks like everything is good. So yeah, what do you think if we take a look into our code? So yeah, so we have import Wavy8, we have from Wavy8 import config, that is basically a config class for starting up our Wavy8 client. Also, we have our classes as we're importing our Wavy8 classes as WBC, and we're importing O's, and also we're importing pandas. So the only thing that we're doing is getting our client collection, and after getting our client collection, we are going to delete it, and after that, we are going to create our wine collection. So we create that collection by starting a new client collection, and instantiating a new client collection, and we're going to use a create function. And this function receives a lot of arguments. One of them are the names. One of them are name, properties, vectorized config, blah, blah, blah. So we can see that name is basically the name of the collection that we want. Also, we have properties. So properties is like the column. You can imagine it as columns or as properties that we want our collection to have. So for example, we can say that I want my wine reviews to have a column called title, or a property called title, and the data type of that column is going to be text. It's going to be just text, and the description is going to be also text, right? So description is going to be this kind of text that we have, and the vectorizer config is another configuration that is text-to-vec transformers. That is the only thing that you should know about this transformer, is that basically it's going to vectorize, that we have seen on the first hour of the stream, that vectorize is basically taking a word and getting like a mathematical representation of that word that my computer can understand. Okay, so yeah, the only thing that you need to know is that we are using a model that is going to create is going to take a text and is going to transform it to a vector, so you can use it. And after that, is going to check if the collection is created successfully or not. So it's going to ask, hey, is my collection already taken? Is my collection already in? So if it is correct, it's going to say yes or no. And then I'm going to import my data set using pandas. So I'm going to create my pandas stuff. I'm going to read a CSV that is inside my data folder, that we can see here that the CSV has some kind of description and title, right? So we have the description, we have the title, and the ID, right? So the first ID is 0, and it says aromas include blah, 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 blah. And also we have the title of the description, right? And the title, we can see that is Buca Bianco by Edna. And so yeah, basically we're just reading a CSV, and for each route that we have in our CSV, we're passing it and storing it into our wine review collection, and we are going to add for each data object that we have in our route that we have just read inside our data, we're going to add it, right? And we're going to do it by by iterating through the wine reviews dataset and store it all in the array to be inserted later, right? So we're going to add a new data object, and this data object is going to be having the same properties that we have inside our collection, and this collection is going to be storing these properties, right? So title is going to have their route, the title, and dot at the end, and description is going to do the same thing. And we're going to do this for each route that we have inside our CSV data. So after doing that, we're going to create a response by just adding a new wine code, by just inserting all the wines or all the data objects of wines that we have done here inside our wine collection. And after that, we're going to pass we're going to insert that. And after that, we're going to fetch the responses if something goes good. If not, we're going to see what happened, right? So, okay, let me see if there's any error, because I think this got, yeah, I think there's an error here, but I don't know what is going on. So let me just print the error if something goes on so I can see it. And looks like it enters into all loops. So I don't know what is going on here. So give me just a minute so we can see and debug this. Yeah, I can explain it. Yeah, don't worry about it. Okay, defendant, don't worry about it. We're going to see it again. So if you need help, don't worry about it. Okay, so if you have just so it's, you say that you install Docker and Docker Compose, right? So you can go here into your README, and inside the README, it has like all the instructions for setting up your environment, installing Docker and all the stuff. So after installing Docker and installing the other thing that you need, the only thing that you need to do is to follow these instructions. That is how to create a virtual environment. And after creating your virtual environment, you're going to get into your virtual environment. And how do I get into my virtual environment? It's super easy. You just need to do deactivate. And after deactivating, you can do, well, I'm there deactivating because I'm already inside my code space. But yeah, what are we going to do is to do something like source, the name of your folder, in this case is virtual environment, or for me is BNB. And after creating, after putting that argument, you're going to put slash bin and final slash activate. And tada, you're already inside your virtual environment. And after that, you need to install all the dependencies that we're going to use inside our project. And yeah, basically for installing all the stuff, we're going to use pip install. And after using install, we are going to use -r. And after using -r, we're going to add the name of your requirements.txt file, that is requirements.txt. And for me, all the requirements are going to be already satisfied, so don't worry about that. So yeah, we can just continue. Let me just clear this. Oh my God. There you go. So yeah, now that we have imported this, and now that we have finished with that, we were seeing the only thing that you need to do is to run your Docker. And how you run your Docker is by running this command, docker compose up -d. And after that, your database is going to be running on 8080. So as you can see here, I'm running my database here. So if you're click inside your localhost 8080, you're going to see that your database is going to be running, and you're going to be having like all the information about documentation, about things that you need to know for working with WAV8, right? So is that clear? Do you have any other questions? Yeah, I also have I also have another error in WAV8. Yeah, I know. I think it should work without it, like with this version. I don't know what is going on. But if that is the case, I think the only thing that we need to change is the WAV8 client stuff that we are using here. So I think for fixing that, we can go here, and I think there was some kind of connect to your cluster. Oh yeah, you're right. We need to pass our URL, the URL of our local host, right? So let me get inside WAV8 again. Um, and it says that we need to pass the URL of our WebA cluster URL. So for me, I think it is this one. So I don't know if this is going to work. No, what's the problem communicating with your WebA endpoint? Okay, give me just 1 minute. So let me go into my code space, and I think for doing that, I should open my port. And for opening my port, I should just right click inside it and cambia, and instead of changing the port visibility to private, change it to public. And yeah, I'm going to try it again to see if this is working. So let me just load this and go here and try it again. Blah, 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 blah. Yeah, there you go. So I'm going to paste this again and let me try to connect. GraphQL was not found. What do you mean? Is it running? Yeah, it is running. Um, it says I don't know why. Yeah, probably it's just a warning. Yeah, I think I don't have any problems with that. Guys, give me just 1 minute. I need to do something real quick. Right, I'm back. I'm so sorry for that. Yeah, so sorry. I had to get a package, but the building is like 32 floors up high. So yeah, let me just see the comments to see if everyone is ready. Oh my God! So there looks like there are a lot of problems. All right. So I think the FedEx thing take me a long, like 8 7 minutes or something like that. So I'm so sorry for that. There was so much about the time. Yeah. So let me just read some kind of comments. So let's see if we can maybe run our Wavy 8 because we just have like 7 minutes left. So yeah, I'm so sorry for that. Yeah, I think we need a second part for this, like for setting up our rack application because there was a lot of theory, there was a lot of stuff that we need to learn for learning how to run Wavy 8 and how to connect Wavy 8 with our database and all the stuff. But yeah, let me um, read you. So it says I have the same warning. Yeah, we had the same warning, right? So I had the same warning too. I never opened it 8080. I have to shut down my Docker container and BNB now. Share pause section. No, I tried twice and had to give up. I was spooked by my GitHub code spaces, out of resources, and that made up my mind for me. Yeah, that is normal. Don't worry about it. Like usually those processes take a lot some kind of time because they're running containers and they're pulling up a lot of information and data from the internet, so you don't need to worry about those kind of images and things like that, so don't worry about it. It's it. When I docker ps I had the Java UI. It does it is this UI that we are seeing now on the stream, the Wavy 8 Think UI, but for connecting it to our database, we need to run first our database, and after running our database, we need to pass the URL of our database, like localhost or something like that. In my case, it is the URL of the code space to Wavy8, and after that, we're going to try to find out after I did code Docker code spaces down B, did I Docker PS and they were all shut down? Did it take long time for the model to download, decompress in your Docker container? It took quite a while for me. Yeah, but were no issues. 100% CPU rich. Okay, yeah. Uh, there's no UI. It's live. I'm good, I think. And I'm stuck with the. Yeah, I think that message is just a warning, so you don't need to worry about that. What you need to do now is to go to your URL of your, for example, I'm going to code spaces, and for example, my YB8 is running at 8080 on my code space link. So my link is variables space line blah 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 8080.app.github.dev version 1. So I'm going to pass this URL to YB8 on my YB8 cloud. And for getting here, the first thing that you need to go is to log out from the dashboard. And oh, I don't know what happened. Boulevard UI. Yeah, so you need to go here in again to the login of YB8, and instead of creating a YB8 cloud on YB8 database on your cloud, you can use your URL here. And for example, I'm going to pass my URL here, like HTTP variables space line blah 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 app GitHub dev version 1, and then connect. And after that, everything should be ready to go. But we have an error here about 44 message path B1 and GraphQL was not found. So I don't know what is going on there. But yeah, another thing that we can try is that instead of using our local host here in our YB8 client, using a client from the cloud of YB8. So yeah, I think we can do that if we are not, if this is not working for like trying to get into my, yeah, if you're using your local machine, that should be no problem. What you want to do is again, run your YB8, and after running your YB8, taking the URL of your local host and passing it to the login section inside the YBA cloud platform. And yeah, but I think that I'm thinking of is that instead of using this, we can just use the YBA cloud services, like the one we saw before. So I'm going to log in into my YBA cloud services and get into my cloud. And as I showed you before, we can create a cluster. So I have a cluster here. I'm going to connect with it by just using WAV8 and importing my OS. And instead of using my WAV8 local instance, I'm going to connect to my WAV8 cluster that I have here, right? So I'm going to pass this here. So I'm going to go into my code space again. And okay, so I have already WAV8 and I have already my OS libraries imported. So I'm just going to change this here. So instead of starting the YB client here, I'm going um, to stop the Docker, all the Docker instances. So I think I should do, okay, let me shut down my Docker Compose. So for shutting down my Docker Compose, I think I need to do shut down Docker Compose. Compose stop, Docker Compose stop. Yeah. So I should do something as Docker Compose stop. And yeah, it is going to stop all my current instances of my Compose instances that I have running right now. Yeah, yeah. We're using the other alternative of getting into WAV8. And inside WAV8, using the alternative of getting your cluster inside your cloud, and after generating your cluster, just copying this piece of code for instead of setting up your WAV8 database like locally, doing it on the cloud and connecting to the cluster in your cloud and running your WAV8 database on the cloud as always. All right, so we just have 2 minutes for it. I don't think we're going to get into it. I'm so sorry. Like we don't have enough time. We should get another part for finishing this stream. I know that was a lot of information. There was a lot of stuff that we saw in the stream, but yeah. So because of this, I think I'm going to close this up. But yeah. So let's just try to make a recap of everything that we saw. So let me share my screen again just to show you everything that we saw this stream. Share my screen. Oh yeah, I think no, you're not seeing it. Yeah, I'm sorry we don't have enough time for seeing all this information. Yeah, we need all to calm down. These were two really knowledge-based thoughtful hours. We learn a lot. We learn a lot of theory. We learn a lot of new technologies like WAV8, like using Hugging Face and all the stuff. If we had a second part, that would be awesome. I think the only thing that we need to do for finishing our workshop is to connect to our cloud cluster, and after that, running our Python environment for getting all the wines inside our document vector into our vector database. So yeah, let's just recap real quick for finishing the stream and setting up everything. So what we learned? We learned what is RIG, what is real augmented retrieval augmented generation operations, or like these kind of new LLM chatbots that we kind of want to use. We learned how the technology of LLMs were. We were on the second part of the generation of Harak that was generating our search engine or a search query engine, and after that, what we should do was importing LLM from our from Hugging Face. In this case, we did it. It was on our and our Docker Compose already. So if you take a look into your Docker Compose, you're going to see that we're using the T2B, the transformer image, and that image is taking a mini LM L12 version 2 LLM. So we were actually working with LLMs in this side. And also we learned the challenges of LLMs, the challenges of racks, and also some examples of how the rack works, how augmented LLM prompts work, how we can use this kind of architecture for creating our own knowledge-based chatbots or our own knowledge-based applications for using LLMs for expanding the knowledge of these LLMs. And after that, we learned some theoretical things like semantic search, like also what is an embedding and how we can use embeddings, real-world examples, and how semantic search work, and examples of how we can use the semantic search for example, the wine classification or the wine retrieval stuff. Yeah, so I know that was a lot. I really love to have a second part for finishing the stream and finishing all the setup that we need to do. I'm so sorry for the FedEx thing. Yeah, I wasn't expecting it, but yeah, I hope that you at least learned something today. If you did, thank you so much for being here. I love being always with new hackers. I love seeing all the hackers learning new things. Don't worry about like getting frustrated. Jackson, like everything is new. Like we always learn some new things, but this is why we are in a community that encourages you to learn new things, and also we learned a lot today, so don't worry about it. You're not the only one learning. Like Green Joshi is also learning, so don't worry about it. Like we are a community. We're here to support each other. So we're here. I encourage you to keep learning. I encourage you to finish the example that we had here. And yeah, thank you so much for being here. I hope you enjoyed and you learned a lot in this stream. Thank you so much for being here. I think Thursday I have another, or Wednesday, I don't know, to be honest. Yeah, I think Wednesday I have another stream. So thank you so much for being here in another Global Hack Week. I'll see you in 2 days, and in 2 days I have another stream. I don't know which stream is. I forget about it. Yeah, we're going to create our first image classifier. So if you want to learn how to create an image classifier for classifying kind of images, go here. Learn a lot with me. We're going to learn a lot of theory. We're going to learn a lot of practice in how to use TensorFlow and Python for image classifying. So yeah, thanks so much for being here. I see you in 2 days, and have a nice Global Hack Week, and I'll see you next time. See ya. Bye.